Cool. So, hi everyone. Um, so I have something to contribute. I was asked recently by Michael, hey, do I have anything to contribute about the Scala 2.13 support to Apache Spark integration? So basically, maybe some people don't know, maybe some do. At least I'm pretty sure the committers to the Spark integration do. It was quite a so the context goes. We deployed the open lineage Spark integration into our own internal pipelines here at Booking, and the hopes, that things would just work because we had identified a set of volunteer people who would run this in their own Spark pipelines on our on-premise Hadoop clusters, and it worked beautifully. And they were like, okay, fine, let's go to our new pipelines, which are running cloud, running different versions of Spark, and unbeknownst to us at that point in time, different versions of Scala. We loaded the jar into the images and expected it to run without any without any hassle, only for the jobs to fail spectacularly because the conflict in Scala major versions, or Scala binary versions as they're called. So the process, why this happens is a bit technical, but basically, when we compile Java code, the compiler will inject the the full class names or full type signature of a method, right? Which includes what its return type is, what its method name is, and also what its input parameter types are, right? It'll inject that into the class file. You may not be able to see this if you open a class file because of the bytecode that actually gets written there, but if you decompile it, you can see it. And so when you're calling, for example, a method in Apache Spark, like you're telling, I have this logical plan object, and you're saying, give me your outputs. So in Apache Spark, I can actually share my screen for this if you want. But the Apache Spark, well, sorry. Yeah, it's over here. Cool. So what happens is, this is just plain old Java code, right? I have a demonstration factory, loads of demonstration, right? And this demonstration is just an interface that returns a java.util.list string, all right? And I have a thing 2.12 and a thing 2.13. What they are is not important. Just know that they have these on it, right? And this is Scala code for those that don't know. And when a Scala developer writes Scala, right, they see this. They see sequence, right, of string. And likewise, if I go to the source code for thing 2.13, once again, they see sequence of string. Absolutely no problems. All right. The Scala compiler does some magic when it's compiling for 2.12 and 2.13, where it will transform this method into its full type signature. In Scala 2.12, that is this one. This gets compiled to essentially scala.collection.sequence, right? And in 2.13, this gets compiled to scala.collection.immutable.sequence. I'm probably typing, there's a typo in my, yeah, there is a typo. But basically it's two different types. And when the JVM sees that the same method has two different type signatures, if it doesn't know about the type signature, or rather if the type signature of the actual implementing class doesn't match the type signature it expects, it throws the classical runtime error, as you can see at the bottom here. So if I go to my Gradle tasks and I tell it, okay, run with thing 212, right? So this is going to run the code up here, right? Against thing 212. Unfortunately, Gradle has to compile again. Right, and it's like, okay, cool. My applicable Scala version is 2.12. My runtime is telling me I'm 2.12.12, and I can see I get a list of items. However, if I now say, cool, now I'm going to say run this thing with 2.12, but the runtime is Scala 2.13 essentially, right? It goes and explodes in my face, right? So we start seeing applicable Scala version, still 2.12, right? But the runtime is sitting at 2.13, right? And I then get the infamous no such method error, right? So this is what we were experiencing. And so the solution to this is to essentially take the entire application or the entire project and compile the things that can be compiled against the Apache Spark libraries that are compiled with Scala 2.13 to do that, right? So this is things like app, things like shared, Spark 3, Spark 3.2, 3.3, 3.4, and 3.5, those modules, and publish, have Gradle essentially produce a jar per Scala version, right? So for example, Spark 3.5 now produces a jar for 2.12 and 2.13. And then the trick is to configure app to correctly consume the relevant jars. Gradle allows us to do this, right, without much hassle. And then further, to make sure all of our work is actually doing what it's supposed to be doing, is to have app run its integration test against every version of Spark that we support and with their appropriate Scala versions. So this means when running Apache Spark 3.5.0 integration tests, we're actually going to run the integration tests against the 2.12 variant and the 2.13 variant. Similarly for 3.4 point whatever, 3.3 point whatever, and 3.2 point whatever, right? The outlier here is Spark 2.4. That one was actually compiled with, by default, Scala 2.11 and also Scala 2.12. So in that case, we only compile with the Scala 2.12 version and we only test with the Scala 2.12 version. Hopefully that explains what's happening. It is quite a challenging effort, particularly because the different versions of Spark require slightly different class paths, and it can lead to some interesting runtime errors. But you can have the screen back.
Thanks for the work you're doing, and it's, I think, a great contribution. We should always get the chance to review years faster.
Yeah, no problems.
Don't worry, we'll get back to all of them.
Yeah, no worries. Thanks for the reviews, by the way. And at least the feedback in terms of getting those integration tests running when I was going. I can't see the integration tests. Where are they?